and we have to multiply another 8. Yes or no? 8. So both of these are the radiuses. So let me clarify something. So let me write out the formula. So this is equal to minus I naught alpha minus by mass of the boy. So M, and then over here you multiply by alpha R, okay, and then you multiply by the radius again, just to clarify the formula. I don't want you to see, hey, why we have double 8. I'm not going to move on to someone ask me a question. Yes. Why do we consider moment of when? Boy is not moving. Repeat again. Boy is not well. Only when the boy is moving. Good observation. You're not sleeping. We clear? Okay. I think this is more fun than most of the. How many of you came for most of yesterday? You guys are still alive and thinking, bloody hell, I'm dead. Okay. Right. So now we did not. So good observation. Okay? Do not need to consider friction. Note. Do not need to consider FF, as boy is not what? Sliding off relative to the wheel. Okay, relative to the wheel. So for now, we have a relationship which is equal to 392.4 times 8. So it's equal to 3139. So I get rid of all the negatives. And then this will be equal to 40 times 8 times 8. 14660. And then just to make things in terms of alpha, so this will be equal to 3139.2 divided by 14660, 0.2141 sine theta. Okay. So from here, this is our equation number 1. Okay. So there's nothing to consider for the wheel anymore. Okay. The trick of this question is very, they want to disorientate you. Okay. What are we going to focus on? The wheel or the boy? Right? The boy, not the wheel. We need to know how much force is required to rotate the wheel. When the wheel is rotating, it is not necessary that the boy will fall off, will slip, yes or no. Until it reaches a certain angle, theta, then the boy will start to what? Slip. Okay? So that's why I found this question very, very distracting. Okay. And later on, we are going to do this one, where you have a person in a barrel that will spin things around and make things worse. Okay, deliberately. But we handle this first. It's not that bad. That one is bad because it's what? General motion. Okay, this one is different. Why? The wheelbarrow is rotating, and when it's rotating, it's also moving in a what? A straight direction. Whereas for the boy, over here, the difference is what? The boy, initially, when there's no slip, the boy is rotating about a what? X-axis. Are we clear? Okay. Don't worry about that one first. Okay. Then the next thing we're going to do, we're going to focus on the buoy. Okay, we are going to focus on the buoy. And we are going to focus on the buoy. Hey, yeah, Eugene, seriously. FOCUS. Okay. And this is where we consider case number 2. When the buoy starts to what? Slip. The constant object over here is the wheel. See it again. Constant object over here is the what? The wheel. Right? Whether the buoy split or not, the mass moment inertia of the wheel is still the same. Remember that. So that's why when the buoy starts to slip, do you consider the wheel or the buoy? The buoy. Who start to slip? So when you run, you slip down. Is it the floor's fault or is it your fault? My fault. Yes or no? Right? You don't. Okay. I forgot to throw salt. Yes or no? So it's us. So I want you to think that way. Okay. Do not memorize any of this. Nothing to memorize. So from here, we are just going to focus on the buoy. I'll copy this whole diagram. And I think I have enough space. Really, Eugene? Hey. Okay. So now, highlight over here. Focus on the little one. Okay. Don't focus on the U. Okay. So when slipping starts, one equation comes to mind is FF is equal to mu static multiplied by N. The mu static that's given to us is 0.5 N. Okay. So the next thing that we do, remember we did a summary yesterday on how to solve this problem. So the only thing we have not considered is we have not considered summation of forces in the what? In the T direction. Okay. So coming down here, positive is coming down. Summation about forces in the T is equal to summation about FP in the K direction. Okay. So you have 392.4. Oh, sorry, you have 392.4 sine theta in the positive direction. So it's equal to 392.4 sine theta. Okay. And then minus by 0.5 N. And this is equal to M A T. Okay. I need a question. I want you to look at this equation, the free body diagram. I need a question. Yeah.
Yeah, so I just went to instruct whatever you think.
Hmm?
Whatever you think, like
Yeah, this is before it sleeps. Before. Okay. So that's not the question I'm looking for. Yes. Of where? Remember what I just told you? We concentrate on who? The boy. Right? Yes. We should. Okay, but I just put down there, highlight the boy. Because when it's sleep, the boy is like you're walking on a bridge, okay? You start to sleep. You don't consider the joint of the bridge a few. You don't consider the structure, okay? Yes or no? So now we focus on the domain of the what? The boy. That's why we did not include the reactions at point X and at point what? Oh, good question yesterday, okay? Make sense or no? Right? Okay, I want you to think this way. Okay, I want you to like, oh, okay, we're going to memorize this. No, no, no. We're going to analyze. Analyze this, but not memorize this. Okay, memorizing get you nowhere. So we form this equation. So this is now n over here, if it's static, are we clear? In dynamics, the n is not equal to the weight of the boy. Someone tell me why. Because you have a what? In statics, right? Why is it n is equal to the mass of the boy? Because summation of forces is equal to 0. For this case, it is not equal to what? 0. So be very, very careful. When I started doing all these examples 3 weeks ago, I thought it was, and my answer was never right before. There's too much statics in me, okay? So from here, we just need to write this out. So 392.4 sine theta minus by 0.5. And the mass is equal to how much? How heavy is the boy? 40, right? And then 80 is equal to alpha multiplied by r. Okay, so radius is 8. Alpha is what we don't know. Then from here, we just need to tidy things up a bit. Okay, I know this is very obvious, but I'm going to tidy things up. 40 times 8, 320 alpha. So this is our equation number 2. And I put note n is not equal to the weight of boy. So you will not make that mistake. And you realize we only consider the what? Consider the boy. Okay. And then the next one we're going to do, I'm going to go for the next page. Come on, page. We're going to do summation about forces in the n direction. Okay. So in the n direction, we have 392.4 cos theta going towards its positive, pointing towards the center of rotation, it's positive. And then n is pointing outwards, minus n. And this whole thing is equal to m omega squared r. Okay, or let me write down the general formula first, an. So this will be equal to 392.4 cos theta minus n mass of the boy, omega squared, not a clue.